So, hello everyone. Ikash Education welcomes to all of you in another session of motivation and guidance series. Today we have Prasant Sir, who is Director of Technology for Asia Pacific and Japan of VMware, as well as a prestigious alumni of NIT Patna. After passing out from NIT Patna, Sir did his Master of Business Administration from Indian Institute of Kolkata. Sir had served as assistant software engineer in TCS for a year. Then he moved to Aricent as a senior software engineer. Today we are going to know the learning and insight of his journey in software development. So, good morning, sir.
Good morning, Akash. Thanks for inviting me, and I'm very excited to talk to everyone today.
So, sir, our first question is: has anyone in your life been a mentor to you? How did their advice help you?
Yeah, that's a very interesting question. Firstly, I would like to say I am not a self-made person, but I'm a mentor-made person. Mentors in life were always there to give me direction to reach my destination. For example, when I was in college and I wanted to know a lot about electronics engineering, we had Professor B.K. Sharma, who was the guiding principal of learning electronics engineering. Then I got into my job and I was trying to figure out how to do patents because I was sitting on an idea for 18 months. And I had a mentor who guided me at that time with the process of how to do patent. And I was able to write 3 patents because of that. And when I started growing in my career and I was passionate about talking to customers so that the products can be built, and to do that, there were many mentors who guided me to become who am I. And what I do today is I help customers to build future of work so that their productivity, profitability, and security increases. Though mentors are a big part of who am I, and I strongly recommend each one of you to try to find a mentor who is able to answer your questions.
And thank you, sir. And the second question is about the upcoming technologies. Means the technology is changing day by day. We know all. But what are the technologies that we focus on for getting a good placement in future release?
Yeah, that very question needs to be underscored by the fact that technology is an enabler, right? Historically, if you see 100 years back, the mechanical engineering technology helped people to move from one place to other. 30 years back, internet allowed people to get and share message from anywhere. And now is the same phenomena which is happening where technology is helping people to get healthcare. Technology is helping people to move from one place to other quicker. Technology is helping people not just to go to office, but to study from anywhere, for example. So if you see the past, there has always been a curve. Each one of your engineer, and you understand there's a lagging curve and there's a leading curve. So the leading curve is the technology which will help you innovate on a new thing. For example, if you look at Casper, which is a technology that is helping people to make medicine for COVID, that's in healthcare industry. If you look at automobile industry, there are technologies like autonomous vehicle and augmented reality and things like that, which is helping cars to move from one place to another without human intervention. Similarly, if you look at education, there's a technology like desktops from cloud, which is helping students to study from anywhere. So the point is not that which technology you're using. The point is that how you are going to use that technology in your work so that you are able to help your customers. So to underline that, every technology that you know is important. For example, if you're a civil engineer and you know that how chemical substances can reduce the heat to make earth green, that's a technology which is very much in demand. If you're a mechanical engineer and you are designing cars, and help the cars to move from petrol to battery focused car. That's a technology that will be there in the future. If you are a electronics engineer and you are helping a healthcare company to build a solution based on technology which will help people to save from cancer, that will be very relevant. So the point is that technology is a broad spectrum, and it's very important that based on your core fundamental skill, you are able to apply that in the industry, which is actually going to make a difference. But I would like to highlight two or three. There's a lot of buzz around um, fast computing, for example, artificial intelligence, machine learning. Talking of networking, there is a lot of buzz around 5G and 6G, as well as satellite-based internet. If you talk about electronics computing, while nano compute is there, there is a buzz which started around quantum computing. If you talk about civil engineering, there is a green cement or technology which makes buildings green. There's a lot of buzz around that. If you talk of mechanical engineering, there is a lot of buzz around how cars will become autonomous, and they will use even electronics part to become more greener and more mobile. So I'm very excited about the overall technology landscape, and I think it's an opportunity for each one of you to to leverage and share what you know and keep learning and doing that more.
And thank you, sir. And
Sure.
the second question is, what are the prerequisites to start machine learning journey? This is the buzz, and you say. So, what are the prerequisites to start the journey?
Yeah, as you said, it's a journey, and machine learning journey will not be different than any other learning that you do in life, right? So there are three steps in any journey. First is a start, which starts with you need a fundamental education how machine learning works. There must be book, there must be um, training which you should go through. Try to find a good book, good teacher, good college. There are many courses you should do. That's the first step of the journey. The second step of the journey is to apply what you learned, and to do that you need to find a problem statement where you can apply the machine learning fundamentals to solve the problem. And that's a very crucial stage, because if you are applying your learning to solve a big problem, you will stay with the problem for long, and then your outcomes will be bigger. But if you try to apply machine learning to very simple problem, you'll be able to solve quickly, but outcome will be smaller. For example, if you are applying machine learning to find cancer detection, it might take ages, but once you achieve that goal, you'll be very happy, and that will be inspiring and changing the world. But if you're just applying machine learning to figure out that whether I can get deliver food or not, it's important, but it's not so big as saving people from cancer, right? So that's an example of the problem which you have to find whether or apply machine learning. And the third and important part is to apply that learning and create more solutions, because in step two you will solve one problem and that will make you the expert of that area, but in step three you'll be able to take that learning out and apply another area. For example, if you applied machine learning in step two to find the best food available in your vicinity of college, and you're able to solve that problem, in step three you can apply the same machine learning algorithms and understanding and logic to find where the best schools are or where the best hospitals are, right? That's an example. Third step is the one where you actually scale and repeat yourself and become expert of that area. So there's always a three-step journey to become an expert or a master of any area. So to summarize, go through a fundamental course, find a problem which you are able to solve, and third is repeat and scale.
And next question is, sir, what clubs or extracurriculums did you participate in college?
Um, I spent a lot of time in the lab. So I was very excited when I got the first microprocessor. It was 8086. And I was fascinated by the fact in 1999, that I could write algorithm which machine can understand. And with that, I made some uh, calculators. Like I could calculate how many peas are being dropped in a bottle, and there was a digital display which could calculate that. Um, and then in the second year, that passion continued, where I went for my internship to a coalfield organization in Ranchi, and they gave us a problem to automate their pension department. So though it feels like a project, but for me it was like a club, because together with me and my few friends, we actually created an algorithm, the high level and low level design, to automate the pension department of Central Coalfield Limited in Ranchi. So if I have to summarize it as a club, it was primarily the computers wherever they were, in lab, in with our customers, in our department. For example, the computer lab was getting set, and we had to procure 1 gig of ISDN line, for which we worked very closely with our professors from computer science department, and helped set up the first LAN network at that time in the college. So I would say my most of the time, if I have to say with the club, it was more towards the technology side, where I spent in college.
Sir, do you think that campus culture has changed since you attended? It has been long time. So what are the changes?
That's a very loaded question. Um, it has two aspects, internal and external. If I look at externally, the whole world is changing. And for example, my son now, who's 9 years old, he is using iPad to go to his school and learn, right? And that's a global phenomenon, everyone. And that is impacting the culture, how internally people are changing, to a point that Stanford has a science called capitology, which actually understand how technology is changing culture and behavior. So now if I come internally and look outside from college, of course, the college has changed. And college has culture has changed because each one of you are able to reach to a broader world, broader community, and broader knowledge base. Um, and which means that each one of you are able to consume a lot of information in terms of books, in terms of events, in terms of opportunity to create something. That culture has leapfrogged, which was not there, I would say, 15, 20 years back when I was in college. So I'm very happy about that change, and I feel it should be accelerated. I feel that each one of you are part of the culture, but there is a possibility that each one of you can go faster, learn a lot, share a lot, and grab a lot, and do more with the resources which are there today, as part of the culture change which is happening in NIT Patna.
So there is a question from Samir Ranjan that he is a non-IT branch and learning machine learning and data analytics. How should he go for projects related to these fields?
And do we know what is Shashi Ranjan's branch?
Ranjan, please mention your branch. He's not from non-IT,
So I assume he must be
civil
uh,
or mechanical.
mechanical. Yeah. So let's take an example. Both, as I said, there is a phenomena of innovation which is
He's
happening globally.
electrical.
Electrical. That's amazing.
Yes.
So we have to look at the the problem in electrical world, right? So if you look at electrical world, there are three layers. There are electrons and protons when we go at very micro level. When we go at a physical level, there's a current flowing in the medium, and when we go above, there are devices which are made because of electrical second layer. So the devices are anything which is battery operated, anything which is motor operated. That's where the electrical industry plays. So now Shashi has an option to apply his IT learning in each of the three areas. For example, if he wants to get into the area one where electron movement is getting understood, that's a place where things like quantum are happening, but they are heavily using machine learning and data because they can understand how electron movements change when the medium change from semiconductor to something which is not semiconductor. If you go to the second layer where we talk about the movements of the electrical currents and waves, that's where there's a physical medium like battery, there is a medium which is magnetic field, right? And each of the area there are trends like digital twins. So if you just do search on digital twins, um, uh, the electrical companies are able to simulate a solar wind in the digital fashion so that they can predict that when the digital turbine will break. And once they're able to predict using machine learning, they are actually going and fixing the real turbine. So that's the physical example or a real example of the physical layer. And when you go up the big layer where machines are being created, the best example is car. So if you look at car, the internal combustion engine or external combustion engine, both of the engines are using dynamos, which are driven by fuels. But if you look at the new design of the new cars, or for example, Ola, if you look at what they did, they made a electrical battery operated vehicle where they use extensively machine learning and data design to ensure that they can reduce the time to create the machines which are electrical in nature. So I would request Shashi to capture as much data as possible using machine learning and then analyze the outcome of a machine learning algorithm so that he can predict and reduce the time taken to create any electrical device in the industry. And that's a phenomenon which is going to grow significantly. Akash, you're on mute.
Sorry, sir. So
No
we have
problem.
next question. According to you, what a student should do to get a better placement regarding placements?
Yeah, that's a very personal thing, I would say, but the three steps of getting a placement, um, I call it 3C. And 3Cs are your concept. The second C is your capability. And third C is the culture. So I'll explain each C in detail a bit. So the first C is concept. You as an individual must be aspired or passionate to work in something. And that's your concept. For example, Akash, you are very passionate about giving the education to the world. I was talking to one other student who was very passionate about working in a high um, high intensity um, semiconductor company, right? So that was the concept where each one of you have something which you are passionate about. In my batch, for example, I had an architect friend who was very passionate about building concepts for building. So his concept was different than mine. I was excited about electronics. He was excited about buildings. But both of us were passionate and had concept about how things will be created. So that's the first C. So you should be very clear on things which are driving you and your concept. The second C is capability, because when you start looking out for getting a job, it's very important that you understand the capability which is required to do the job. Never ever you will have all, but when you go into an interview, they look at you and try to gauge you on a scale that what capabilities you have. So I'll give you a few examples of the capabilities which are very important. Number one is your critical thinking skill, because you are an engineer and you should not just be able to question people, but you should be able to create things. So that's the first capability. The second capability is to communicate your thoughts. For example, communication is a three-way process. We learn, we think, and we speak or write or communicate. So when you're in an interview, it's very important that you are able to communicate back um, what is being asked for. So communication is a very important, not just electronics communication, but verbal communication, non-verbal communication. Everything gets noticed. So that's one capability which is very important. And the third capability is the core capability of a job. Every job has a capability requirement which you should read very carefully. For example, if you look at the job description which is given for electronics engineers, say in DRDO, so they very clearly mention that you have to be a very good student who is passionate about research, has a fair understanding of research, and has a passion to learn new things and grow. That's an example. So similarly, if you go for manufacturing company, they will have a job description. So you need to understand whether how ready you are to have that capability, and how much the gap is, so that you're very honest in your interview. And the third part is culture. For me, which is very important, because culture gives you career, not job. When you join a company, initially you are very excited, of course, because of the fact that you're out of college, you are getting some money, but that excitement fades away very soon. And the reason it fades away is because the company is not able to give you culture of your growth, which means you are doing a job and you're not doing a career. For example, if you are passionate about um, building architecture of a building, or maps, for example, of a city, and you get in a company which is giving you option to design and draw the maps in initial year, second year they take your map and they start making buildings, and in third year you see the building becoming complete, and you will be excited and learn what was right, what was not wrong, and then you make the second map of the building, and that's what your career will grow. So that's a career which you should look at, for which the culture of the company should promote that. And I'm very um, thankful to the professors of our college, because when I was like you, I was trying to understand that what is a driver of a teacher, because they are thankfully or thanklessly teaching us. They never share the hardship that they put behind teaching us. But if you look at their career, that's one of the most fulfilling career, because they are able to create many knowledge brains in the industry. So that's a career, right? It's not just a job. So you should always find the culture of a company which gives you um, a career, not just job. So I would strongly recommend each one of you to think of these three things: your concept of a career, second is the capability to do that career, and the third thing is the culture of the company which you are going to join matches with your aspiration of a career, not just job.
Yeah, that's right, sir. And there is a question from Roshan, sir. He's asking that you are from electronics background, so give some tips like its future and present of electronics department
um, Electronics department in general or in the college?
in general. In general.
Yeah, I'm very passionate about electronics because I got fascinated about how the electrons move, and it has been a phenomena where electrons have been moving in different medium. So if you look at 30 years back, perhaps 40 years back, there were pentodes and triodes, and electrons were moving in electrical and copper medium, right? And someone very smart came up and said that, hey, let's move these electrons in semiconductor because they are more resilient, they are more available, and they are more scalable, and hence started the phenomena of semiconductor based electronics, which is actually supporting pretty much every growth in industry today, right? So if you are programming, there's 8086 processor based architecture. If you are using a phone, that chip is there, in which electron is there, the transistors are there. And if you are using even a watch, a smartwatch, you can see that a small chip is there where electrons are moving. That's the present. Moving in forward, there will be two things which will happen. Number one, the number of transistors will get compressed more and more so that they can do higher compute. That's why you're seeing trends like graphical processing unit or ML accelerator, where you can run, which gives you power to run new applications. However, there are very smart people and companies who are working on something like quantum mechanics, where they want to change the medium in which electron flows. For example, in the pentode and triode days, electrons were flowing in wire. In the era of semiconductors, electrons were flowing in the transistors, which were built on silicon. And in the future, the electrons will not flow either in wire, it will not flow in semiconductor based on silicon, but they might flow in a new medium, which is under research. So if you are very passionate about that, there are many papers on quantum mechanics, which I try to follow and try to learn. And that's how I feel the future of electronics will be, which will leapfrog the whole industry that has not been done before ever.
And sir, there is a question from Ravindra Raj. He is a mechanical student, and because of online classes, he is not able to get the concepts, or he is not able to attend labs. So he is just doing online classes. So now he wants to learn coding and all technical terms in computer science, and wants to get a job in IT industry. So what you would prefer to him to do?
Yeah, so if you see, there are two parts which Rajan is saying, right? First is I'm a mechanical engineer, and the second part is I want to learn IT. And if you want to learn both, it's very hard, to be honest. You can't be master of all. Uh, so Rajan has to decide the 3C, as I said. First, he has to step back to understand that what the concept of career for him is. For example, in my batch, the students of mechanical are actually driving a lot of thought in heavy mechanical industry, and they are kind of thought leader and very senior executives. Historically, the college has proven the people have who have gone in core area also are at a very senior position. So that becomes easy because you are expert on one area. So the first choice he has is to choose between whether he wants to be in mechanical or whether he wants to be in IT. The second step is if he wants to be in IT, then he has to let go what he learned, but he has to learn what's needed. But that will just give him a job. And nobody knows that the job he will get will be there for 25 years or not. So that's like the passion where he has to change his passion from machines to writing software, and eventually he will become a software. And the third part is whether he wants to see himself after 5 to 10 years. So I'm very happy to have a personal chat with Rajan, or perhaps if he can unmute himself and talk where sees himself in 5 years, 10 years, 15 years down the line. That will give him a lot of clarity on things. So I would say to Rajan that he should step back a bit and really try to think through how the success means to him, or what the success means to him, not in just getting a job, but success after 3 years, success after 5 years, success after 10 years, success after 15 years. And I'm very sure if Rajan does this, he will get an answer whether he should go in IT or not. I'll give you my example. I was in third year, and the general trend at that time was the best of the breeds used to go in engineering services and administrative services. And I stepped back and asked myself that, do I really want to do engineering services job? And I lived with that question for 6 months. I talked to mentors, I talked to my parents, I went and talked to the people who were doing engineering services job. I went to their offices, what kind of problem they were solving. And I had a lot of respect for what they do, but then I realized that for me, I wanted to code, and I wanted to be an engineer who is actually talking to machine more. So I stepped back and said, okay, let me get on a journey to write software with machines. But the underlying passion was machine itself. So that was my finding, I would say. So Rajan will have to do his soul searching, I would say, but not to get bogged down into the dilemma of IT versus a mechanical engineer. You are an engineer, and you will always remain an engineer, and you'll always solve a problem. Doesn't matter which branch you are in.
So thank you so much, sir, for having such a wonderful session. I think all the questions are have done. So
Thanks, Akash. I wish all the best to everyone in their learning, sharing, and caring journey. And I wish each students of NIT Patna a lot of success in not just starting with their career, but in future of the career. And I really thank my regards to the great professors of the college who are helping each one of us to becoming better every day. With that, thank you, Akash. Have a nice Sunday, and bye for now.
thank you, sir.
Take care. Stay
Thank
safe.
you everyone for watching us.